Welcome everyone to tonight's webinar for heat pumps for new construction. Um, we have a heat pump webinar series that starts at 5:30 on various Wednesdays throughout the spring and summer. The next one we're going to have will be on July 24th, and that is about ducted air source heat pumps for existing homes. But again, today we're going to talk about new construction, new homes, and air source and ground source options out there that are available. We do have sponsors for today's webinar. All those people under those community partners are our sponsors for our webinar series. They're located in various locations near Eagle County, which is where Walking Mountains is located. And I work at Walking Mountains in Avon, Colorado. So we have CORE there in Pitkin and Eagle County over in the Roaring Fork Valley. Energy Smart Colorado is an organization that's all over Colorado. They help organizations help existing buildings in their communities, homes and businesses make energy efficiency improvements, electrify, things like that. Electrify, that logo is from loveelectric.org. That's a beneficial electrification league of Colorado, and they have lots of great information on their website. Again, it's loveelectric.org. Holy Cross Energy is a local electric co-op here in the mountain region, mostly in Eagle, Garfield, Pitkin counties. Clear is over in the Roaring Fork Valley as well. They have an Energy Smart program and do a lot of energy related nonprofit work. Tri-State is also another co-op. It's a co-op, right, Dave? I'm going to ask you to make sure I have that right.
Oh, it's the
Tri-State?
TNG. It's the transmission and generation.
Yeah, I thought I had that
But
wrong.
they are a co-op. They are a
Oh, they are a
co-op.
co-op. Okay.
They are a
Um,
co-op. They're a co-op of co-ops.
Co-op of co-ops. So Tri-State Generation is sponsoring, and then High Country Conservation Center there in Summit County. They have Energy Smart Colorado helping existing homes, and they also do a variety of sustainability and energy related nonprofit work in those communities in Summit County. So thanks to our sponsors. This is a little bit about Energy Smart Colorado. We don't have to go into detail about everything on this page, but kind of shows you in these areas what nonprofits are available to help with Energy Smart Colorado, with those energy efficiency electrification improvements in existing homes. So depending on where you're located in which county, there's different nonprofits that are housing that program and helping the local communities. And this is Dave. Dave Petroy is our instructor today. You've already heard a little bit from him. He is the owner of NTS Energy. He's a consultant on several energy projects that he has going on. He also does a lot of heat pump specific webinars for us and works with us on some more wider community complex upgrades for buildings. He was a consultant. Are you still doing consulting with Excel Energy? We're just getting really informal
No,
today.
no, no, no.
Okay, all these are previous. He was a consultant
Yeah,
with Excel
previous.
Energy. He was a sustainability manager at Golden Aluminum, founder president Blue Valley Energy. That's HVAC company specific. He's done a lot of ground source heat pump work in the past and has a lot of knowledge of that, which you'll see today from this presentation. And he has a couple other interesting things on there, RMS Electric, and then he has a MS in geophysics. Dave, tell us how geophysics connects to all the excellent heat pump knowledge that you have today that you share with others.
Well, it does help in understanding how things work. That's for
Yeah.
sure.
Yep.
It got me a job in the energy. I was an oil guy a long time, but now I'm not. So
It gives you good insight today into this whole transition we have going on and everybody moving to heat pumps when you've come from that and you have that history.
yeah.
So it's cool.
Okay. Well, let's get going. So hopefully you can hang in there. I have about 40 slides and it takes about 40 minutes. But I think it'll help both of you. Hopefully it'll answer a lot of the reasons you're here. We're going to talk about, the strategies you can use with heat pumps. And Angela, I can give a couple examples of some bigger houses I'm doing now, what we're doing. We'll get into the cost stuff. Um, and then this is important. We'll talk about how you make sure you got a good size system and installed right. So the reason we're here, I just got a couple of slides just to give you an idea of the advance of the technology. So this is outdoor temperature on the bottom axis, And this is the amount of heat the house needs. And the green line is sort of a typical home up in Eagle. And this is how much heat it might need. This was in, say, the year 2000, this thin blue line. This is how much heat the heat pump could put out. And it was basically down to about 30 degrees. And then they were short all this capacity. So really, heat pumps weren't a thing. So they've kept improving, improving, improving. And now basically we're at this point where a heat pump can put out consistent heat all the way down to around zero, and they can go below zero now, down to most of them can go to about the cold climates go to minus 13. So in that case, they tail off a little bit, but basically they can do all the heating except for there's a little block up in here which you combine with supplemental, and we'll talk about the two types of strategies for that. So that was one. The other is efficiency. HSPF stands for heating seasonal performance factor, which says over the course of a winter, um, how well does it heat? The higher the number, the better. And this is since 2000. This is only about the last 10 years. Um, and this is the number, the blue, and this is the percent actual improvement. So a lot of systems now are around in here. 25 to 30%. There's ones, these are sort of the absolute best ones. And the last couple of years, we're still about the same. We're probably about in 2020 because the manufacturer have been working on new refrigerants. So, but there's always been these step changes. And this directly relates to cost. You know, the more efficient, the less cost. So really what's gone on and why these are so good for cold climates now is efficiency, capacities. This was very big. Defrosting was a huge deal, especially around freezing temps when you get ice. And then there's typically lots of storms, not as many in Colorado because we have drier air, but still around the teens where what happens is these things get iced up and they don't work as well. Now they've got ways they go into a quick reverse mode, melt it all off and continue to work at a high capacity. And the other is actually to be able to do well heating below zero. So those four things really are the things that make up why we have cold climate heat. So looking at strategies, we have more tools. And this is more like the distribution. Just looking at, you've got the old whole house ducted systems, which can be air source or ground source. Um, Overall, and thinking about the house now, the key thing is you can integrate the heating, cooling, and all the indoor air quality, the ERVs, the filters, everything in one. The duct systems, people don't love them. As an architect, they get in the way. They also complicate the construction process. And you can do these as dual fuel or strip heating. I'll explain that later. Then you got mini splits, which is really probably the big jump forward. You've got all these different ways to put different units throughout the house. Their air source. They have heating, cooling, and filtering integrated. You have to figure out ways to do ERVs and humidification independent. Obviously, no ducts. The big difference there is you've got more equipment to maintain and gaining homeowner acceptance for the units. And I'll talk about that because I've been trying to do that with some of the homeowners. And then you've got in the high country, everyone likes the radiant in floor more. But now with air quality, smoke, and it getting hotter, it's almost becoming more mandatory to integrate some kind of air cooling system. So you can go with a boiler and an air source combo. I'll talk about that a little bit. But ground source is good. And you've got something called air source hydronic. I'll mention that. We have to talk about that on tape. Obviously you got to build two systems. So that drives up the cost. And the air system can be whole house ducted or mini split. So depending on how much of the house you want to do. I think one of the big things, I think most people are starting to know this, but it's worth repeating. With these better houses, there's really the difference between radiant and air system is in terms of comfort and quality is so much less than in the past. I mean, the walls, the floors, well insulated are not going to feel cool. You don't have cold windows. You don't have air leakage. So just that radiant feel, that's a big thing. The other thing about air, people would say they're noisy, they blow, but these air source heat pumps, they're variable speed, they're quieter, less airflow, they're better response. The technology is just a lot better. They basically set it up and it likes to just flow a little bit of air all day to keep the temperature. So this is pretty much the same for everyone. As a homeowner, you don't want to have issues. Um, and as a contractor and architect, same thing. Um, and we'll talk a little bit about design in terms of for extremes or not for extremes. Um, and there's a lot of options. So really, it's a balance between first cost versus energy use, operating cost. And I think the other thing I should put in here really is is complexity. As much as we have lots of tools, we should really try to keep it simple if possible. So now, more than just saying, "Oh, we have a house with this load, let's just put a thing in the basement and duct it." Just a little bit of philosophy in the big house. Is it a real big open concept with high ceilings? Do you have the ability to put ducts in? As an architect, do you even have room for chases or ducts, or do we need to think about some kind of mini split strategies? What's the attic availability for second floor that makes it easier? And the basements, often maybe just put a little radiant in the basements and use ERVs for fresh air. Finding out for large homes, east, west, north, south, finding out that, for the new homes, a lot of people obviously want it to face south. They want a lot of glass, or they want it to face west. So the main floor, it's very different in terms of all the needs and the responses. So basically, design the system for those two sections of the house is really critical. Um, so with traditional ducted systems, basically, one level home, I would say that the big thing here is really no. You need to have at least two thermostat controlled zones for quality, comfort, efficiency. I mentioned east, west, north, south. The height of the ceilings is also big. And now, you can, with the basement, in the past, everyone's like my basements, it's cool or hot or something. One way is you just put a couple little vents in for cooling because you hardly need any. And you can select electrical in for comfort. Electrical now, since a lot of the rooms don't need a lot of energy, it's not a bad option. Multi-level homes, typically you're going to want to go with two heat pumps. And now I have a slide. Their sizes are a little bit constrained in terms of the max size of the heat pump. So really going to go with a couple systems. You could try to do one system with vertical duct and three zones. Maybe save a little cost, but honestly, it's hard to get a high quality system because the designs of the ducts, the curves, the insulation, making sure it works well. In this day and age, that's getting to be harder. So mini splits are, they've been around now a while. Everyone's familiar with them in general, but some of the details. So there's wall units. Every manufacturer now makes called designer wall units, and I should really put a picture up. They're basically 2 inches slimmer, and they might have a nice black glass face. They're trying to make them look a lot nicer. Slim duct is a really good one. That fits up in, and we'll talk about that use. But the nice thing I like about that is it's hidden and you can do a couple rooms off of it. So think of it as like a mini duct system, which is easier to do and implement. And then you've got flush mount. I get mixed reaction on these with homeowners. Some of them are like fine with it. They're like, yeah, that's okay. Others don't like the looks of it. These are nice from an architect, construction, builder point of view in that they fit between the joists. Usually they're off the wall by like one joist bay. This one's in the middle of the room, but if you put them in front of like sliding glass doors or say above cabinet areas, not right, but just off, they're more into the house, so they're not as obvious. Square ones are kind of nice. They're more um, for commercial, but you can put them in residentials for new homes if you can box it out. The nice thing is they have very good control. The airflow goes four ways, um, and there's more airflow control. Not many people look at the floor units. I think if you've got room, or depending on your space, they're actually pretty nice. And and so here's my little call to Angela, calling all architects. And the thing about these units is how do we make them look nicer? I've come across some really nice designs. You got to have enough air, but putting them in there, sometimes putting these drops, integrating them in that. And I found when I show people this, and some of the people, they're like, yeah, I like that. I'm going to do that. So it's a way to get more acceptance. Now, when you're going to do, so is it practical to do a whole house with a mini split system? If it's a little place, one or two bedroom, let's say you have four major rooms. Sure, you can put four big units in, or you can put the slim duct above the closet between the two bedrooms, get one out of each. You need access from below, so closets and bathrooms are good. Um, Mitsubishi has a really good system in the sense that they can put a conventional air handler, so you can actually have your second floor be a duct system, and then the first floor you can put a couple of these in various rooms. The small rooms, I'm finding out that really toe kick heaters are awfully nice. They fit under cabinets. These rooms are well insulated. They hardly need anything. I've even just a house now, we're putting in three 110-volt small toe kick heaters for small rooms. The other thing is with these is you got to have good placement for airflow. You want them on the outside walls, but you want to think about the distance it's going to throw. And I think you can think about it 10 or 12 feet is a good way to think about it. I've had some really big rooms where the capacity of the unit is big enough to heat the room, but the throw wouldn't be good. So instead of just doing one, we would put two on opposite walls. So that's just a thing to think about. And how many of these units can you put on an outdoor unit? I mean, they can say six, seven. There's some that say six, seven, eight, but really four is kind of the limit. Um, you have to be careful with four because you can't have a big one and little ones. Two to three are pretty common. So with radiant systems, I've touched on it a bit, but now I've spent a lot more time talking with the customers about, you know, where is radiant super important to you? Like what rooms, where's cooling important? I mean, I think this is the big trade-off now in the high country because I used to be, I want radiant, I don't really need cooling, but now it seems to be that, you know, you've got this trade-off. One thing that's coming around more is to use air with electric floor warming. Um, and the way that works typically is you'll say, all right, what rooms? They'll say bathrooms, my office, maybe my kitchen. Otherwise, I'm pretty good. And we're not using the electric to heat the room, just to warm the floor. If you use the electric to heat the room, it's not a good way to go. Um, so really end up with this balanced strategy of radiant and comfort and energy efficiency. And what you can think about is the air system with a heat pump is super efficient for 3 seasons, and it's very fast responding to the days where we're changing 60 degrees. Whereas if you've got radiant in in gypcrete or in concrete, it's slower to respond. And then turning the radiant on in the winter for the cool months is a good. So this is a good balancing strategy between comfort, energy, efficiency overall. Um, and then I mentioned about just the small rooms, the basement. I hardly with these new basements. Basically, you don't really hardly need any heating or cooling at all, just the tiniest amount. It's more important to think about and make sure you've got some kind of energy recovery ventilation system in the basement because you really need to get fresh air in and out of the basement. Um, and one thing we'll talk about ground source heat pumps. I have a few slides about those. But for them and air source heat, air to water, which are sometimes called um, hydronic systems, heat pump hydronic systems. If you're going to use those with radiant, you need to make sure that you design the radiant in-floor system to work at low temperatures. Um, They don't work very efficiently with high temperatures. Like, and in the past, boilers might be set. They design it so the boiler can drive the floors or at 120, 130. That's not good for these systems. It also is inefficient for boilers too, but that's something to keep in mind. That's actually critical. So the heating sources, obviously the heating air source, heat pump, whole house, mini splits, but now ground source, and the next three slides I'll talk about it. But they're kind of nice. They have a lot of flexibility. You can have a system that'll do a whole house ducted. You can have a single unit that'll do radiant and ducted out of one box, or you can have just a radiant. The thing about it is they're very, very, very expensive. There is a nice 30% federal tax credit, but even so, the cost is quite high. And there's a lot of variability in Colorado because of geology. But if you're building a big house, 5 tons or greater, it's something worth looking into, because you need multiples of the other system, whereas these, with one system, it can drive it. And you do lower the heating costs more. There's limited installation, but it's a pretty good the contractors. There's enough designers, contractors been doing it in Colorado, people 30 years. So the knowledge, and you can get someone to do it. The hydronic ones, they're okay. They're kind of small right now in terms of the capacity. Um, so you can do them for like a single unit could do 2 to 3 tons, but the cost is quite high, 2 to 3 times a boiler system. If you've got a big house, I mentioned about ground source, you can, if you want to be a little more mm, energy efficient than just going with a boiler, you can combine one of these with a boiler, and it'll do, say, 6 months of the year with the heat pump, and then the boiler does the rest. And you also can use it to do um, the cooling. But I have to say, not a there's a couple designers, a few contractors, so it's a little bit harder to get these in. I wish the market was more developed, but it's not quite there yet. So ground source heat pumps, the major components is called, one is the loop, which is the pipes down into the ground or horizontal. I'll show pictures of each. That's one. Then the manifold is the trench where you connect all these together into bigger pipes. And then you've got the flow center pump. So it comes into the house. Here's the flow center. So this is what's pumping all the fluid through the pipes in the ground to bring in your heat or send the heat out. And then obviously the indoor unit. Now, one thing nice about ground source heat pumps is the units are all inside. So the result is they last a bit longer than the air source heat pumps. I would say 5 to 10 years in terms of the indoor units. And here's the types of units. This is a box, looks like a big furnace, but it's got ducts. Here's another one, though. It looks similar, but the beauty of this is actually it has inside has another component which allows it to create hot water for the hydronic radiant system. So this one box can do radiant in-floor heating, air cooling, and air heating. Of course, and this is the case, there's more commercials or retrofits. This is the case where you don't have air and you can just basically drive your radiant with a ground source heat. Now there's horizontal loops and vertical loops, and horizontal loops are trenches or sometimes in big pits. Um, they can be quite large, but it can be a big savings if you have a way to, these are out in the Midwest a lot. A lot of people have their own tractors or ability friends to dig these inexpensively. You hire professionals to put all the loops together, but then you backfill them. But also, if you've got moisture in the ground is a very good conductor of heat in and out. So the more moist ground you have, the smaller the trenches and the pits can be. They're typically about 4 feet down, 4 to 5 feet. Um, we're kind of dry, so that doesn't help. There's a few of these out east, but in general, because of our geology, the dryness, etc., the value of land that's not near as prevalent as in other states. So we mostly go with vertical drilling. Um, these are not very big holes. They're about 5 or 6 inches in diameter. They go down 250 to 300 feet, 15 feet between each. And then you have a trench, you dig it right next to all of them. It's about 3 feet, 3 to 5 feet wide, that pipe in it. And then you put this fluid in water with some methanol, and methanol is pretty harmless, and it circulates through the pipes. And these pipes are all sealed, special techniques, so they're going to last. Right now, people put 50 to 70-year lifespans on them. I'm not sure what's going to go bad unless we were getting earthquakes or something. Now, the thing you have to understand how these work is basically they're pulling heat from the ground, and the ground temperature at these depths is a few degrees above your average annual air temperature. So in the Front Range, you can think the ground tends to hang around 55, up in the high country, maybe 48, 49. And so what happens is during the winter, as you're going to times when you're pulling heat out very quickly, the ground around the immediate vicinity will drop in temperature, which is okay. These systems can actually operate all the way down to the loop temperatures of about, I think, 25 in most systems. Um, but what you want to do is design it so that you have enough of these loops in the ground, a big enough section of ground that even though you're pulling out heat in the winter, it's not going to go below like 35 degrees because that keeps the efficiency up. It's a trade-off. I could put tons of loops in and have a really ultra efficient system, but it costs prohibitive. So what happens in the winter? This might go down, then we go into spring, the ground temperature is going back up, balances out. We go into summer, you push heat into it, the temperature is going to go up a few degrees. It might go up to like 70, which is nothing. These can operate at very high temperatures. Basically in Colorado, our heating designs are twice the cooling design. So it really has to do with that. So I mentioned they're not cheap. It's sort of for a long-term investment. So the cost is 175 to 250 BTU. So this is a 40,000 BTU system, 70 to 100,000. You've got a big tax credit though, so it really knocks it down. But to compare it, a similar whole house air source um, would be about half of this, about 20 in the 20s. So still costly. But this is the Cadillac, the best system. The thing about this is it depends where you are, what your geology is, etc. For the drilling, um, some places it's relatively easy, and the drillers know other it's a higher risk. So what about let's get into the efficiency. How much energy are you saving? What's the cost factors? So there's something called COP, coefficient of performance, and basically that's a measure of if I put energy in, how much heat do I get out? So 95% furnace is 95% efficient. So I put energy in and I'm able to convert 95% of that gas to heat. Electric resistance heat is one. Basically every watt into that gets used up as a heat. Heat pumps on the average are around 3. The ground source a little bit more. The average over the winter, over the heating season. In the mild parts of the heating season, October, March, that number is going to float up to 4 because the temperature outside is maybe 40 or 50, so the heat pump doesn't have to do as much work as when the temperature is 10. So it varies between, say, 4 and 2 roughly. On the average, it averages out to 3. So 3 units of heat moved for 1 unit of energy in, so only 33% of the energy. If you're comparing it to old pure electric heating, which really nobody puts pure electric heating in these days. I hope not. You're going to save 65%, 70%. If you're out somewhere remote and you don't have other options aside from electric or propane, is also expensive. This is a big deal with the retrofit market because it's very, you'll see in the next slide, it's very well worth it to to swap heat pumps for propane. Um, Gas is not as expensive, and but depending on how gas fluctuates. So gas over the last few years roughly goes between 80 cents a therm and 120 a therm. Well, that's pretty big fluctuations up and down. Electrics goes up. Basically, how it's fluctuating, it's going to be in any given year, the gas system might be 10% more, 10% less, back and forth, back and forth. So whereas 20 years ago, there wasn't even close. So to me, it's on par. And that means, in reality, 10 to 20 bucks a month in our heating season, one way or the other, depending on the year. 2 years ago, heat pumps won easily. This year, gas is leading. This down here gives you, I think, this I think fools a lot of people, myself included, when I first started looking at this stuff in more detail for Colorado. This is the outdoor temperature, minus 20 to 70. This is the percent of annual energy use at each bin. And notice, you think that we use almost all of our heating energy when it's cold, but not true. Between 35 and 65 is one third. Between 15 and 35 is half. So above 15 is basically 82%. And now we only have 18% from 15 down. And actually, when it's really cold, it's like 10%. The interesting thing about this is all the design, all the sort of trickiness about designing heat pumps right has to focus on this little bit of time and these hours. All this heat pumps have, it's a piece of cake. And this just shows the temperature and shows how, basically for 8.5 months of the year into here, super easy for heat pumps. Heat pumps, cold climates go all year round, but just relative, where's it easy? Where does it have to work hard? I'm not going to spend a lot of time going through this. Propane, it saves a bunch of money. This is, the system options and how much it saves. I think the key thing here is um, right now is a great time to be investing in this if you're building a new home. Now, you'll find system costs all over the place. Try to get sort of the median. The main thing is what's the difference between these cold climate heat pumps. This is with an air handler or with a propane furnace. So this would be an all electric version. This would be called a dual fuel. The furnace not doing a lot, doing like 10% of the heating, 15% just when it's really cold. It's about 4 to 4,500 price difference. But notice that with the rebates, and they vary depending on your utility, this is kind of where Colorado is. We're one of the states that does have nice programs for this. So really your costs are a tiny bit lower with the heat pumps, or they're pretty much equal. So, I mean, in this case, it's really a no-brainer, about the same cost, and your heating costs are a lot less, and your cooling costs are a lot less too. The gas, so this is the same comparison. And this year I had 83 cents a therm, 11 kilowatt hour. I've been doing some numbers this year. It's like 14 and 90, so a little different. But in general, a little bit here. In this case, all electric heat pump with the air handler and the electric doing a little bit when it's really cold. This would be gas furnace. So, that unit saves some, that unit's a little more. You do reduce your natural gas by a ton. But again, similar numbers in terms of first costs. Um, but the other thing, the cold climate heat pumps are going to save on cooling also, because these cold climate heat pumps are really sort of top of the line. They have very good cooling. SEER2 is cooling. The higher the number, the better. Whereas people putting in AC, they'll just put in middle of the road. So you do have better cooling also. Um, people want to know, some people want to know, how does it help with GHG savings? This is 2020. This is the amount of GHG per year. This is 2027, this group, just different combos. So you can see it relative. This is a car, cars around here. So heating does is pretty big. It's, heating, cooling, and cars. And these are the heat pumps. So back in 2020, this is Excel data in terms of the emissions density. They had not as much wind and solar, more coal, have been changing things. So notice heat pumps were a little higher than pure gas, but the hybrids were a little lower. 2027, though, the heat pumps dropped way down. And actually they're on track for this. If I put 2025 numbers in, um, they're pretty good. They're in between, they're on track. And so you'll get a lot of savings over the course. I'm working on another calculator with a colleague. He just did some numbers. You're looking at big savings. You're looking at 70 to 90% over the 15 years. And this isn't assuming perfection by the utilities. This is assuming that they keep going along, even if they hit a wall at 80% renewables, there's still a lot of savings. I kind of like this picture because I don't know, it's nice and colorful, but really look at this is where your energy is being used. These are the big three. Um, there's a lot here, but they're all little things. So you can only do so much by doing these things. When you replace them, you should, but it gives you a good picture. Um, so let's just talk about the design. So what you might talk to some people. I think it's getting less and less, even over the last 2 years. But what would happen is, man, my heat pump didn't work when it was really cold. It just couldn't keep the house warm. And the other one was with all electric systems. I had people calling me and saying, "Whoa, man, I'm looking at my bills, and they're pretty crazy." Well, there was a few things that were just not done right. First of all, they weren't sized right. Typically, the heat pumps weren't big enough. Um, they used the wrong temperature for the climate zone, or they didn't think about when it's really cold. They undersized the units, or in some cases, they weren't really installed very well, which hurt the efficiency and the capacity. um, and a couple examples. So I had someone from Denver call and say, "Man, my electric bill is through the roof." We found out that they had put in a heat pump, and below 30 degrees, they were using all electric. The heat pumps, it wasn't running. So it was all the way up here. So about 40% of their heating was all electric. Now, it turned out we talked and they came and put a little bit bigger system in. And part of it was they had the settings to go over to the electric at that time. So in the end, working with them, we got it down where I think it was like around 15 to 20. So now the electric's only doing 18%, which is a noticeable impact. And then there were other cases where it's very cold. The heat pump was set up. It sure heated to 5, but when I got below, it didn't do it. And we'll talk about that. So the first thing is you might talk to some contractors, or if you're a contractor, you might be presenting and say, "Oh, it's a cold climate heat pump." Not all cold climate heat pumps are the same. There's standard tests down to like 5, and they have the standard sheets, but really, there's a couple things you got to know. All right, how cold does it really? What's the low temperature can really operate? And there's sort of classes of heat pumps. Some go to -5. The better ones go all the way to -13. Some online advertise -15, -20. I don't know about that, but they are creeping up every year. So the nominal capacity is not the critical capacity. So someone will say, "Well, I have a 4-ton heat pump." Well, even if they say I have a 4-ton cold climate, it could be different. It needs to be able to hold that capacity to all the way to zero within like 90%. Uh, but then you say, well, okay, what does it do at -5? What does it do at -10? What does it do at -13? Some of the manufacturers publish those numbers, or, 2 or 3 negative numbers, and they'll say, this is the capacity. For example, Mitsubishi says at -13, they have a curve and they lose about 20%. So you know that. Other ones will have a Daikin also publishes numbers. Other ones don't. So at below -5, you're not sure. The other thing to know is in terms of the biggest sizes right now, a little over 4 tons is kind of the biggest ones out there. You don't really, I've looked a lot. There'll probably be some 5 tons, but they're not really out there. And up in the high country or even in the front range, we've got altitude. So you have to derate for altitude because the air is thinner. So in the end, the systems produce a bit less, and this is what your HVAC designer will take into account. Now, there's another category, high efficiency heat pumps, um, tier one, sometimes they're called, and those can heat down. They can heat the house down to like 15 to 25, depends on what you size it. And then you can combine it with a dual fuel, like a gas furnace. That's a reasonable strategy. For new homes, I wouldn't, and it's a great strategy for retrofits because you've got all these other constraints. But for new homes, I would really lean a lot heavily toward the cold climate because, first of all, you'll get better, lower emissions, and it's just more. You're doing more with the heat pump. They're more designed that you don't have to depend, especially with electric. You're not going to do this strategy, but I just want to throw it out there. So how do you size it? Well, first of all, you've got these great houses you're building, super insulation, not leaky. You've got to do the model, and it's important to know the heating loads at these negative temperatures. Now, as a designer, and according to a lot of codes, um, there's called a standard design temperature. So Eagle, it's -6. So if I go into my program to design -6, what's my house load at -6? Denver -1. Okay. So then the dilemma is, it's you have to think about, all right, -6. Does it ever get cold at -6? It does get cold at -6. Am I allowed to like put in a huge system? Not supposed to, but I got to make sure that when it gets a polar vortex of -20, how much heat do I need and are you going to be comfortable? And so that's why you really need to look at these numbers and say, hey, all right, I need to kind of get an idea. And this is kind of the way that designers look at things. So it's a little bit complicated, but it looks pretty. Heating load goes from 0 to 60,000. So this is how much heat I need. These are my temperatures outdoor. This is hours per year. So what I have here is the green is um, the heat pump. So this is the specs for the heat pump. Remember, this is the heat pump sitting on a nice factory floor, running its or ASHRAE test in a test lab, running nice, and this is how much it can put out. In the real world, there's a chance it could be a few percent less for a few reasons. One is over time, like any piece of equipment, these things degrade a little bit. It's only probably I haven't yet defined like research on this, but I think it's on the AC world, it might be a 0.5% per year or something. So over the course of 15 years, you say 5%, 7%. And then you've got, oh, well, you had a contract with your HVAC contractor, and he came out and put great filters in all the time. And, well, that kind of went by the wayside, and you got dirty filters occasionally. And the other thing is sometimes you have very harsh conditions, super wind, a lot of, icing. The heat pump's going to work. They're designed to handle that, but it's not as efficient. So basically, it might not be quite as up to this point. The other part, though, is the red line. And that's I go in and try to build the perfect model. All the insulation, all the glass, everything. This is what it says it needs. Well, actually, in a fortunate way, the models are generally pretty conservative. Um, and have found that in general, need a little bit less heat. So this is kind of shows representative of a band of a less heat. So you've got maybe units aren't going to do as much, but you also need less heat. Basically, though, here's what I'm looking at. I say, I want to have enough heat pump capacity at around 0, somewhere between 0 and 5, somewhere in this range, that a heat pump does all the job. And then this little bit to -13 actually a little bit further, I've got supplemental. I'm not total supplemental. I'm still using the heat pump, but now I have supplemental. And this is to give you a number idea of, well, what's the risk? Like how many hours is this? So this is the number of hours. The thin line is the average, like it's the 30-year bin average. And you can see we're down to like right in here at 5 degrees. We're at 25 hours a year. So we got 5 nights. Uh, and it gets lower. Below 10, it's not many at all. This would be a very cold winter. I basically said, well, what if the winter's 10% colder? This is a warm winter. So you can see we're spending a lot of brain power trying to figure this out because you don't want to be cold, but the risk is lower. So, um, so this is just to summarize a lot of what I just said. You want to size it for that. You don't want to use a lot of supplemental, especially if it's electric. Um, then if you've got high efficiency heat pumps with furnace, the ones I talked about mostly for retros, but should you do this for your house, it is an option. It's probably save you a couple thousand, but if you're building a three or $400,000 house, I don't know. Uh, and then when in doubt, upsize a half a ton. Now you'll see a lot of things people say, don't, the big mantra is don't oversize. But I think they're thinking in the past where you put a furnace in, it was like double the size. We're talking just a little bit of difference. So let me pick up the speed a little bit. So if you got a full electric system, you better not put a lot of electric, like 10 kW at the most, typically 5 to 10. If you need more than that, you might need a bigger heat pump. A nice thing to do if you're going to have wood stove, masonry stove, or something in there, that's going to help. You're not going to have to be worrying about it that much. So what's a reasonable comfort level in the polar vortex? If you look at this, you can say, to me, it's like if the house gets a 60 2 or 3 nights a year at nighttime, but then everything's cool, you know, that's probably reasonable to not way oversized. Because I can't put in huge amounts of electrical. It's going to cost a lot. A couple things to do if you have EV, you're going to put EV charging, you can share these circuits, or you can put a little propane as a backup. If you've got natural gas already there, you're going to have it, or the developer's going to have it, the dual fuel is nice. You only end up using about 10% natural gas. If you've got big a house, you're going to want to do two systems. To just give you a couple examples how we're mixing things up. So I have one house. We're doing a ducting in the core of the house. It's a long, thin house. I've got a small dedicated mini split for the master suite on the north end, and there's an office and a bedroom in the south end, small dedicated mini split with a wall unit there. In the master suite is slim duct. In another house, we did the second floor with a ducted system, and they had a big open concept first floor, and we're able to put like one of the wall units above the fridge and another in the area where the client was very happy with that. So these are ways to combine. Um, Basically, without reading all this, you'll get the slide. It basically says when you have these mini splits, you also have to figure out the size of those units. And it's pretty easy to do actually, but different sizes for different size house. I think the key thing is you kind of have to have them similar, somewhat similar size. They can't be way. Getting a good system. I talked a little bit about it. Get the specs. Actually talk about the warranty. This is really where they stand by it. What's the warranty? And I always recommend to my clients to get the extended warranties for these. Are there distributors in Colorado that carry the broad product line? Does it meet all this? You're going to see so many things on what's going on in the industry, like everything else on the internet. Is it just constant relabeling? They'll throw labels on anything. Oh, it's this brand, it's this brand, it's this brand. It can do this and do that. But if there's not a distributor in the state that's carrying it, I wouldn't go with it. Okay, couple quick notes for 45, long time. You don't want to end up shoveling out your heat pump in the winter to make it work. So you can put it up high, have it covered, and have a nice covering. You've got to get it up off the ground. My recommendation, a lot of people put it like 12-inch standard or 18, but I'd say, if you're way up in the high country, you put it above the average snow depth of maximum up. So, if you're up at Vale, you might want to put it much higher. Um, and just make sure that the line sets are well insulated and you've got effective drainage. There's been examples of this stuff draining onto sidewalks, etc. Noise, I wouldn't hang this like right next to my bedroom. They're generally pretty quiet, but you want to be a little bit smart about that. Ducks, just make sure these are great ducks, have to be sealed, well wrapped. I mean, the codes are a lot tougher now. And I think one thing is thinking about where to put the units so the zoning is easy. We used to just stick the unit like way back in the corner of the basement. Well, you might want to think about putting it kind of in a little closet in the middle or something. Um, and mini splits, because you got a lot of lines, you have to pay attention to where the lines go. They're easy to run. I mean, on the outside, they're just like little gutters. You want to make sure they're accessible. And it's pretty easy to do, but these are a few things to keep in. So try to summarize. I think at this point, heat pump systems with either all electric or dual fuel are really the standard now. I mean, there's almost no reason to have AC. It's like having a car without reverse. I mean, you're buying a unit with a heat pump that can heat and cool for 9 months of the year, 8, 9 months of the year. AC, use it 3 months of the year. A lot of design flexibility. First costs are on par. Um, I wouldn't be wedded to one strategy, especially like in the architecture world. Being aware of this, you can discuss it, having lots of conversations with the architects up front. What do you want? What'll help? Sizing is critical, etc. So I think that's it. Oh, last little bit here. So you saw the big three energy use: heating, cooling, driving, domestic, and now there's a lot out there about. Everyone seems to be, oh, this doesn't work, that doesn't work. But honestly, no, heating and cooling, these are great technologies. It works great. Driving is the other big one. It's about the same as heating and cooling. You've got all sorts of choices. And domestic hot water heating, if you're looking at, the new thing, heat pump water heaters is a really good option too. So that's all. Thank you.
Thanks, Dave. I would like to mention that if anybody's looking for those rebates or tax incentives, I'll be sure to send out a link to
Oh, sure.
a page that we have on the Energy Smart Colorado website that talks all about different tax incentives and provides links on where to go to find more information. And then for rebates, I would just say make sure you really talk to your local electric utility, whoever your electric provider is, before you make those decisions about building new construction, and find out what their rebate requirements are. For example, Holy Cross Energy, I think, requires that you do not have a gas line in order to get their rebates for heat pumps on new construction. So definitely check those out. Unfortunately, a lot of the nonprofits housing Energy Smart Colorado don't rebate new construction. Most of them just rebate the existing buildings when they do have rebates available. However, there are a few that have new construction rebates, so you can certainly reach out to your local nonprofit as well to see what rebates are available. And then, Dave, the only question we had was from Angela, and I think you hit on it in your webinar, in your discussion just now, but can you use the ground source heat pump for cooling as well?
Oh yeah, yes, yeah. Ground source heat pump. It does heating and exactly. Yep. And the
And
and the combo ones, you can do heating, cooling, and the radiant. It's really nice.
and is there a certain application or way that you have to do the cooling if you want to have cooling in addition to the heating for ground source?
No, no, use the same duct system that you would use. Same way. Yeah.
Great. Anybody else have any questions before we end the webinar today? I know that was a long one. We had a lot of really good information in there. All right, you are welcome to reach out to myself or David anytime, and we'd be happy to answer your questions on things we talked about here. We do have, again, that webinar coming up on the 21st. Do I have that right, Dave? 21st, I think,
Uh,
for
look, 20,
ducted
wait,
systems, air source
24,
heat, air source, oh,
24,
24th. I'm sorry, 24th for
24th.
ducted ducted air source heat pump systems for existing homes. So join us on the 24th, and I will send out a follow-up email to everybody that registered so they can have a link to this recording as well as the slides and some more information that will be helpful in that email. Thanks, everybody. Have a great day.